So the next concept we are going to study is finding the expression for angular momentum. So presently in last class we discussed, I think in yesterday's class, we calculated the expression for kinetic energy and as well as momentum for a rolling. Am I correct, everybody? Please respond.
Yes,
so for a rolling object, either it is a disc or it is a sphere or it is a ring or whatever it is. So what is the net momentum, everybody? Net momentum is equals to mass into velocity of center of mass with respect to what, guys? Velocity of a center of mass with respect to what, everybody? With respect to ground. So that is very important. Ground, or we can say platform. So then we have calculated that what is the total kinetic energy we have been calculated in a rolling motion. Of course, rolling motion means it is a translation motion, and as well as it is what motion actually?
rotational motion.
Rotational motion. So the total kinetic energy of a body which is in rolling, we have been calculated that what is the formula, everybody? Half mvc square. Vc means what? Center of mass, plus half into I into omega square. This is what the derivation we have been done in yesterday's class. Remember, in physics, if you want to become like whatever, if you want to be like pioneer or good in calculations and numericals, understand the question, theoretical part you have to be very clear. Unless you are crystal clear, there is no not at all useful even practicing 1,000 questions. That's why the derivations and all, whenever time permits, just have a glance when you're traveling in bus and all, 5 minutes to 10 minutes, if you have seen, then it will be very familiar for you in that, because understanding derivation is very important. Simply sitting and making useless talks in the bus is nothing going to work out. That's what I'm saying. So now related to this, let us solve one question. Two things we'll solve, and then we'll proceed the last one in our today's class. That is what angular momentum, derivation expression for angular momentum in a rolling. So let us take, before that, based upon the kinetic energy, there will be a question. So understand there a disk or whatever it is, a solid sphere. I'm taking as a solid sphere. So whose center of mass and velocity is actually V, center of velocity. So solid sphere. It is a solid sphere. So mass is equals to 2 kg. R is equals to 2 meters. Radius is equals to 2 meters. Angular velocity is equals to 3 radians per second, and center of mass, which is equals to 5 meter per second. Velocity of center of mass. So that is what is the question they have given it. Now we have to calculate the kinetic energy. So what is the kinetic energy formula, everybody? So total kinetic energy equals to half m velocity of center of mass square plus half I into omega square. So if I substitute half into, what is the m, everybody? 2 into velocity of center of mass, which is 5 square. 5 square means how much, guys? 25 plus I into. So can you tell me what is the momentum of inertia? Inertia of a solid sphere. Inertia of a solid sphere. Yes, Rudreshwar? Inertia of a solid sphere which is passing like perpendicularly to the screen. You can see, imagine perpendicularly to the screen. All of you, please. What is the moment of inertia? I told you, I have sent you the PDF also yesterday. I think day before yesterday, learn all the moment of inertia. I want solid sphere moment of inertia. I is equals to, at least see and tell, 2 by 5 mr square. Unless you learn this, there is no progress, I'm saying. Realizing your potential is very important. So that's all. So if you don't know this, then how you can proceed? That's what I said you to learn all. Mass is 2 kg and radius is 2 square. That is 2 means 4. So which is 4. So which is equals to 4 4s are 16 by 5. So that is what is I. So 16 by 5 into omega. Omega is 3 square means 9. So which is equals to 2 will get cancelled. This is what, 25 plus 16 9s are how much? Yes, please. 16 into 9. All of you? Nobody's answer. 16 9s are how much, guys? 16 9s are? Yes?
144.
144. So 144 divided by 10, which is equals to how much, everyone? So 25 plus 14.4, if I add it, which is equals to 39.4 joules. That is the total kinetic energy of a pure rolling mud. That's all it is. Understand, everybody? Solve it. Clear, brothers? Everybody? Absentees, make it fast. Call to that Rishi is there, Rohit and Murali. Somebody give a call to them. Mr. Pradeep, understanding? Please make complete attention. Otherwise, there is no use of studying. That's what is my expectation. Again, there is a lot of dilution. I'm getting today also. Somebody is informing me what is happening. People are not concentrating. I don't know. Mr. Sai Karthik, are you solving?
Yes, sir.
Yeah. Mr. Rudreswar, I sent you Sri Chaitanya book, combined book for physics. I was saying that, and MSET material also.
Yes, sir.
Yeah. One book that Disha tuition something is there, book 3,000, 4,000 pages. It is actually Andhra MSET supply state government exam. It is for engineering entrance. So there is I have gone through that. So hundreds of questions are there, and it's a good revision also. You can see that. So even you can go through that. Many things will be there. Just I'm saying you correct. Time is only parameter. There is no end for the questions. You can keep on solving until NEET exam comes. Still there will be a questions. That's what that many questions are there. So use the time wisely. Unnecessary diversions not required. Finish it fastly. Then next we'll proceed. Next one, everybody. Clear? All of you, Princey, understand, Princey? So now we are going to find the angular velocity. So imagine there is an inclined surface. It's not inclined surface, just like a curved surface. This is what is the surface. Okay, Pradosh? Inclined surface means this is the inclined surface. This is not the inclined surface. Understand, Rudreswa? It is like a curved path. Clear? All of you? So now a ball is there or a ring, you can take it. So I am dropping a ring whose mass is m and our radius is r, which is initially at rest. So now having a velocity v of the center of mass and angular velocity omega, and height of this inclined surface, this is what is h. So now when it will reaches to at this point, if it is releases, definitely you can see that when it is coming down, do you think angular velocity remains same? If it is rolling here, angular velocity remains constant. But if it is rolling like this, is it angular velocity remains constant? That is what is my question. Everybody?
No, sir.
No.
No, sir.
Angular velocity keep on changes. That is what it is. Manu and Samya, are you doing? So that is what. Imagine it is a smooth surface. So smooth surface means no friction. So any kind of object is coming down, is rolling. So angular momentum, the fastness will be keep on increases. Now the question is, find the angular speed or whatever it is, angular velocity of a ring when it reaches the bottommost point. Do you understand, everybody? Bottommost point. That is what we have to do it. So let's start now. I will teach you all. See, it's time to learn. So how focusfully you have to make it. Remember, these concepts are extremely important for NEET and JEE. Whatever the stream you go, there will be a majority like there is no question paper without asking the questions from rolling motion. That is that much importance in our NEET and JEE preparations. So for this, we have to find it. So what is that? They are asking an expression for angular speed when it will reaches to the bottommost point. When it will reaches here, what is the angular velocity? That's what. So from this, we can say angular velocity remains constant or varies. Everybody, remains, varies. So we all knows that V is equals to omega r. From that, omega is equals to what is the expression? Everyone, omega is equals to
V by R.
V by R. That is what you have to remember. So to deriving this, you can see as it is rolling coming from a certain height, I will use it to derive that conservation of which energy? Conservation of coming down, guys. By the time you must have an idea. What energy? Converting potential energy into what energy? Kinetic energy. So that which will use it? Conservation of mechanical energy. So what is the conservation of mechanical energy formula? Fastly, everyone. Conservation of mechanical energy. Call to Rohit, somebody. And you are missing Kadiri. Make it quick, everybody. So conservation of mechanical energy. What is the formula? Princey, you have to involve, Princey. You are not no more class 10th and class 9th. So Manu and Samya also. What is that? Initial potential energy plus kinetic energy equals to final potential energy plus final kinetic energy. So we all knows that initial kinetic energy is what? Because body is in rest. Initial kinetic energy is what? Everybody. 0. And finally it will came to surface. So that final kinetic, final potential energy is also what? Everybody,
0.
please. 0. Understanding? And finally it is came to the end point. So at this point, you can see it is having a it is a rolling motion, pure rolling. So that it will be having two. What is that? Translation motion plus translation motion, rotational motion. That's all. So kinetic energy. So what will happen? Initial kinetic energy. It is at height h. So height h means what is that? Draw mgh. Am I right, guys? Speak loudly. Mgh plus 0, which is equals to 0 plus final kinetic energy is what? Half m v com square plus half I omega square. Will you all agree with me, everybody? Please. Mr. Udresh, clear?
Yes, sir.
So we all knows that V is equals to R omega. So can I replace in place of V is equals to R omega? Because we want to find the omega. Am I right, guys? Which is equals to R omega square plus half I omega square, which is equals to mgh. Now you can see this will turn up into half into m R square omega square, which is equal, plus I plus I. What is the ring I equals to anybody? What is I value of ring? Please. I value of ring, brothers, with respect to perpendicularly to the screen. I value. Is there anybody in meeting? Is Narayan? Perpendicularly z axis. What is I value? I value of a ring, guys. Very, very bad this is. mr square. So mr square into omega square. Any problem for anybody? You can ask me. That's all it is. So half plus half, which is equals to 1. So mr square omega square is equals to mgh. So both the sides mm will get cancelled. Omega square is equals to gh by r square. And omega is equals to root over gh divided by r. Any problem for anybody? So this is the expression of angular velocity when it is rolling in a curved path from a certain height. So please all of you calculate it. Any problem? Anyone? Anywhere? You can ask me. Ring inertia theriyada, Rudreswar? What is the ring inertia? Yes, please. What is the moment of inertia? mr square. If you don't know that values, there is no use of studying. That's what I'm saying. There will be continuously that values are keep on coming. You have to always work. Any doubt? Anybody can ask me. Understand, everybody? Yes, please.
Yes, sir.
So this is what is the concept of calculating the kinetic energy, and as well as we have been calculated now omega for a ring which is falling from a certain height in a curved path. So it is not an inclined surface, guys. Inclined surface means straight line. It is a curved path. So if that's what I'm saying. So that is why angular velocity is keep on changes. So now the next concept is we are going to find angular momentum expression for angular momentum in a rolling. So that's what we are going to make it. So always with respect to ground, we have to make it. So let me take some rolling object whose angular velocity is what? You should all involve. I no need to call anybody's. Angular velocity omega and velocity of a center of mass. What we can take, guys? Velocity of a center of mass. VCOM. Are you clear, everyone? And having a mass M and having a radius. Radius R. Okay. Now, you all can notice it when we are calculating the angular momentum. Already we have studied two formulas for angular momentum. Can you tell me, everybody? Angular momentum for translation. Translation, what is the formula? Pradosh, translation motion, what is the angular momentum formula? Imagine there is a mass M. There is a mass M who is moving with the velocity V with respect to a center or a point A. So what is the angular momentum formula? We already studied in translation motion. Angular momentum with respect to A, which is equals to what? All of you, speak loudly. This is R. So R into M into V. Am I right, guys? Translation motion. Is it correct?
Yes,
Yes? Yeah. So translation motion. So angular momentum with respect to a point A is R into M omega. So now, if you take any kind of object which is rotating with respect to axis of rotation with angular velocity omega, so if it is a rotation, can you tell me pure body, total body, what is with respect to center of mass? What is the angular momentum? With respect to the center of mass, what is the angular momentum? Everybody, please respond. I omega. Am I right, everybody? Yes, please. All of you?
Yes, sir.
Yes. So now, in a rolling, if you have taken, what do you mean by rolling, guys? We all knows that. Rolling means what? All of you. Rolling means what? It is translation
Rotation.
plus rotation. Translation plus rotation means what is the total momentum? Angular momentum is equals to. Anybody? Total angular momentum is equals to translation. What is that actually? R into total mass. Actually, it is a small mass I have taken. Total mass is what? Capital M into V plus rotation means what is that? Speak, Ra. Pradosh is not audible. I into omega. So this is what it is actually. Now, if you all notice it here, can you tell me this is the translation moment, angular momentum with respect to what? Anybody? Angular momentum with respect to what? All of you. Angular momentum with respect to what, guys? Center of mass. Understanding? So that is what. So total angular momentum is equals to angular momentum with respect to center of mass plus angular momentum. This is for what? Whole body or particular mass? This is for
Whole body.
body.
Whole
So
body.
angular momentum of a whole body. So that is the expression for calculating the angular momentum of a entire system of rolling. If the body is in rolling, this is the expression for total angular momentum. Now we are going to derive the proof. So the proof is the most complicated one. As perfect as possible, you can concentrate. So make sure 100% you are aiming in this, then only you can solve. Along with me, you also need to proceed, because vector concept also again we are going to use here for deriving this. Okay, so yesterday's class, and you can see we have expressed it for distance and velocity and expression with respect to ground. Can you tell me what is that we have found it? Anybody? Distance and velocity, two expressions we have been bought it. Anyone can tell? Day before yesterday's class. Yes, Mr. Rudreshwar. Three expressions we have done. Distance of a particle with respect to ground is equals to distance of a center of mass with respect to ground plus distance of a particle with respect to center of mass. Next, velocity of a particle with respect to ground is equals to, speak loudly everybody, velocity of a center of mass with respect to ground plus velocity of a particle with respect to center of mass. Same way, acceleration of a particle with respect to ground is equals to acceleration of a center of mass with respect to ground plus acceleration of a particle with respect to center of mass. These are the three expressions we have already solved in the last, I think, day before yesterday's class. Am I right, everyone? Acceleration we studied in yesterday's class. Am I right, Ra? Please respond, everyone. Clear?
Yes, sir.
Now you can see, so in a angular momentum, when you want to find it, so we have to do it at a particular point with respect to a particular point. I'm taking a point A. So with respect to center of mass, what is the distance between them? We used to call it as, everybody? Let me take it as a what? R. What we used to call? Everyone? R. Understanding, Ra? So that is what. So angular momentum with respect to a point we are finding. So with that, let us see the proof. We have to calculate it now. So proof, please make sure you are very, very clear. So now I'm inserting a circular motion. Let me take the shape of it so that it is very beautiful. So this is the circular motion. So it is rotating with the, let me take the point A and center of mass here. What is the velocity of a center of mass, everybody? What is the velocity of a center of mass? VCOM. Clear? And it is rotating with the angular velocity. How much, Ra?
Omega.
Velocity omega. Clear? So the distance between this point to the center of mass, what is to call, everyone? Can you tell me? What is that called as? R? Yes, please. R. Understand, all of you? Vector form we have to represent it. Now, as we know, if it is a rolling object, so let me consider it will be having a infinite number of masses, because the total mass is capital M. So I am taking a small masses. So it will be containing many masses. I am choosing a mass M1 here. What is this, everyone? Please respond. What is that? Mass M1. Actually, what does it mean here? With respect to what? Everybody? With respect to? ground. Clear? So with respect to ground. So now the distance between this point to this point, let me take it as a, what I can take, anybody? Your choice. What I can take? Can I take it as R1? Is it okay, everyone?
Yes, sir.
That is what it is. So now if you observe very carefully, so can you tell me what is the linear angle this one? M1 point. L1 is equals to, speak loudly and tell me. What is that, guys? R1 into, yes, R1 into M1 into V1. Am I right, everyone? Will you all agree with me? Velocity. Yes or no? Velocity of this one is V1, M1. If I take some other particle, M2, let me take M2. Then what is the L2? L2 is equals to what, everybody? L2 is equals to R2 into, responder, M2 into velocity of the second particle. Is it right? Will you agree with me? Yes, that's what. So now you can see like that infinite number of particles. We can make infinite number of particles. Now you tell me, what do you mean by V1, Rudreshwar? From this I can take velocity. This is particle means I can take V1. Can you tell me what is the V1 from this, everybody? V1 with respect to ground is equals to, what is that? Velocity of center with respect to ground plus velocity of V1 with respect to center. Will you all agree with me, guys? You speak only, I
Yes,
can.
sir.
Otherwise you cannot. So can I replace it now in place of V1? What I can replace, guys? R1 into M1 into, in place of V1. V1 means what I can write? Speak here. V1 means what I can write? I can replace with what? Velocity of center with respect to ground plus velocity of one with respect to center. Am I right or wrong? Everyone?
Yes.
Same way. Second particle, tell me. You say only, I'll proceed. Otherwise, it is impossible to solve this derivation. Yes, please. Second one. R1, R2. R2 into M2 into what will happen here? VC with respect to ground plus V2C with respect to center of mass. That's what. So V2 is equals to VC with respect to ground plus V2 with respect to center. Am I right, guys? Like that, if you want, write V3. V3 equals to what, brothers? VC with respect to ground plus V3 with respect to center of mass, and so on. We can write it. Will you all agree with me, guys? Everyone?
Yes, sir.
Yes, sir.
All of you observe. So with respect to this point, this is R1. Then with respect to this is the vector. Imagine this is. Then let me take this is like a, what is this? With respect to, this is with respect to what? R1 with respect to, this is R1 with respect to ground. This is what? R1 with respect to what? R1 with respect to, everybody. R1 with respect to what, guys? Center
Center
of
of mass.
Center of mass.
Understanding? Now, observe very carefully, brothers. In a vector addition, let me take, this is the one vector I have been taken. It is the following arrow. Vector addition, you have to remember. This is RC with respect to ground. What is this actually? RC with respect to ground. And this is R1 with respect to center. R1 with respect to center. This is RC with respect to ground. This is R1 with respect to center. Now I want to this one. Can you tell me vector addition? What will happen, guys? Vector addition.
Triangle mass.
Yes. What law will use it, everybody? Mr. Narayan, are you able to catch it? What law will use it? Triangle law. What is triangle law? Vector A plus vector B, which will give you what? Vector C.
C.
Understanding? So means in the sense of, this is R1. R1 with respect to the ground. So means from that I can say R1 with respect to the ground is equals to what? R1 with respect to the ground is equals to what? RC with respect to the ground plus R1 with respect to the center of mass. Will you all agree with me, guys? Everybody? Yes? Yes, everyone. Same way, I will replace next R2. R2 with respect to the ground is equals to, what will happen? RC with respect to the center of, RC with respect to the ground plus R2 with respect to the center of mass. Is it okay, Rudreshwar? Can you able to catch it, Mr. Murali? Princey? Understand?
Yes, sir.
That's all. So, can I replace now in place of R1? Can I replace this one in place of R2? Can I replace this one? Everybody? Now you tell me replace and tell me what is the equations will come. L1 is equals to, speak loudly. L1 is equals to, in place of R1. Even with respect to ground, you can avoid it. It's nothing wrong. It's nothing saying, if I say R1 means it is with respect to ground only. If I say RC means with respect to ground only. That is you have to remember. Okay, guys. So now tell me, L1 is equals to, please make it everybody. In place of R1, what I can write? In place of R1. RC with respect to ground plus R1, R1 with respect to center into M1 into VC with respect to ground plus V1 with respect to center. Is it okay, Wa? Understand,
Yes, sir.
Pradosh? This is a one. Next, 2, second particle. What is that? RC with respect to ground plus R2C with respect to center, which into M2 into VC with respect to ground plus V2C with respect to center. Am I right, everybody? Are you clear? All of you understanding? You all should speak. Yes, that's all it is now. So now you can see like that I can write it for many particle. Next step onwards, unless you do, you cannot be. Now we want it what? Total. So L total we want it now. So this is the biggest expression we will get it. But still I will try to make you very simple, very as simple as possible. So make attention very carefully. Now let me first multiply this one with M1 VCC because I want to teach first time you are studying. So it will very slowly will study. RCC plus R1C bracket I'll put it. Any problem? Pradosh? Into. Let me finish this one first. M1 into VCC. What will happen, guys? M1 into VCC. Or let me take it now. M1, can I put it outside, guys? Is it okay for you people? M1, can I put it outside first? Little bit, sometime. Okay, I will multiply this one. A plus B and C plus D. What is the formula we can say? A plus B into C plus D. This is what is the we have now. So can you tell me what is the terminologies will happen? So I will put M1. We are going to add it, guys. Total. At total, we are going to add it. So M1 here inside, what will happen? RC into VCG. What will happen, Ra? RC into VCG. Pradosh, speak. RC into VC. Am I right? So RC with respect to ground into VC with respect to ground plus. Second one, RC into V1C. RC with respect to ground into V1 with respect to center of mass plus. Next, R1 with respect to center into, what is this? VC with respect to ground plus R with this. What is that? R1C with respect to center into V1 with respect to center. Will you all agree with me, guys? Am I right or wrong? Please respond.
Yes, sir.
Yes. Plus, next M2. M2 is there. M2 again I'm putting outside. Now you tell me what will happen this one. Again same. With this, next with this, next with this, and next with this. Tell me everyone, you should speak. Pradosh, RC with respect to ground into VC with respect to ground. Next, plus RC with respect to ground into V2C with respect to center plus next R2C with respect to center into VCG with respect to ground plus R2 with respect to center into V2 with respect to center. Will you all agree with me, everyone? Plus it will be continuing M3, M4, M5 like that it will come. Any problem for anybody? Please. Yes. Clear? Everybody, Mr. Narayan, understand this step?
Yes, sir.
So now, Rudresha, let me simplify it. Let me go with the mass. I will multiply it because it is very necessary. So I will take it. Mass is applicable for everything. So for your purpose, I am writing one more step so that you all should not confuse. I am taking only 2. So M1, it is multiplied with everything. So you can multiply M1. M1 is with everything. Am I right, guys? M1 into RCC, M1 into VCC, M1 into RCC, M1 into V1C, M1 into like everything it will be. Any problem for anybody? Are you all okay? Yes, please.
Yes.
Yeah. So now if you observe very carefully here, first you observe RCC into VCC. Okay. Next here also RCC into VCC. So, and everywhere, M1, M2, M3. So, we all knows that sum of the masses, M1, M2 plus M3 plus so on, which is equals to what? Everybody. Yes, please. You all should speak. Total mass. Am I right, guys? Can I write it as a total mass? Everybody will all agree with me? Yes? Please respond.
Yes, sir.
Yeah. So, M into So what is a common thing here? You can see RCG into VCG. Here also RCG into VCG. Next also what will come? RCG into VCG. Next also RCG into VCG will come. So can I take it as a separately, Pradosh? M into RCG into VCG. Any problem? Anybody? Yes? Plus. Okay, va? First term over. Rudreswa? Okay, va? Clear? No response. Nobody is. Okay, next second term. So second term, what is that? You can go through that. Your choice. You tell me. What way we can simplify it is based upon purely your side. Second one, RCG V1C. Here RCG V2C. Next one RCG V3C, like that will come. See, in this all something is common. Can you notice it? RCG is common. Here also RCG is common. Next also RCG will come. So what else I can take? Everybody? Can I take it as a RCG outside? Rudreswa? Okay, va? RCG into. Any problem? Please respond. So what is remaining? M1, sorry, here. M1 into V1CG. M1 into V1C. Plus next one. M2 into V2C. Next one. M3 into V3C, and so on it will come. Any problem for anybody? Rudreswa? Understand, Ra? Yes? Pradosh? Clear? So the second term also over. Second term. Next third term. R1C into VCG. Next one. R2C into VCG. Next one. R3C into VCG. Like that will come. So what is common, guys? Now you should speak. What is common? What is common in that? Everyone. R2. Here see R1C into VCG. Here R2C into VCG. Next one R3 into VCG. Which is commonly we are seeing? Everybody.
VCG.
VCG. That you loudly understanding. VCG is common into. I'll make. What is remaining? M1 into R1C. M1 into R1C. Any problem for anybody? Yes, please. M1 into R1C.
No,
Clear? That's what it is. Next, what else remaining? M1 into R1C plus next one. M2 into R2C plus so on. Next, last term plus. Last term, R1C into V1C. R2C into V2C. Next, R3C into V3C. Is there any common term? No common. Have you noticed it? Is there any common? No. So,
No.
what will happen? M1 into R1C into V1C. Next plus M2 into R2C into V2C. Any doubt, Laksha? You can ask me. Plus and so on. Any problem, guys? Till here, any doubt in this step? Okay, Rudreswa? Yes? Now, yesterday we have studied velocity of center of mass is equals to M1 V1 plus M2 V2 plus and so on divided by M1 plus M2 plus M3 plus and so on. Same way, can you tell me RCOM is equals to, what will happen? M1 R1 plus M2 R2 plus M3 R3 plus divided by M1 plus M2 plus M3. Is it okay, Narayan? Prados, understand this? Clear? So this is what with respect to what, guys? This COM with respect to what? Everybody? COM with respect to what? Yes, please.
Ground.
Okay. Now, all of you observe, second term and third term, I will multiply both numerator and denominator with M. Capital M divided by capital M. And this term also, capital M divided by capital M. So that by this time you all understanding. It will be total mass will become, what will happen? This will become VCM. This will become VRM. And sorry, RCM, RCOM. But with respect to what? With respect to ground or with respect to center of mass? With respect to ground or with respect to center of mass? Everybody? Yes, please. With respect to ground or with respect to center of mass? See here. Center of mass. Understanding? So, but we know this is with respect to ground. So, what will happen now? Capital M into RC into VC plus RCG into this whole term will become, can I write as a VCOM with respect to center of mass? Any problem? Any problem, Rudreswa? This whole term into M. Clear? So what is the velocity of a center of mass with respect to center of mass, which is equals to what? Yesterday I have taught you. With respect to what? Velocity of a center of mass with respect to ground, it is existed. It is existed. Velocity of a center of mass with respect to center of mass, which is equals to what? Everybody? Which is equals to
0.
Same way this one. VCG into this whole thing except M. This whole thing will become RCOM with respect to COM into capital M. So that R with respect to center of mass with respect to ground, it is existed. But RCOM with respect to center of mass is not existed. So this whole thing will become what? 0. So plus this everything you write it as usual. M1 into R1C V1C plus M2 into R2C V2C and so on. So this whole both terms will become 0. Only this equation, right? Meeting is going to end. You come back and we'll continue. So L total, angular momentum total is equals to capital M into RC into VC plus this whole term will become 0 plus 0 plus last term M1 R1C V1C plus M2 R2C V2C and so on. It will be clear, everybody. Any problem for anyone? You all can ask me.